information of the actual situation in the field. So you have a lot of sensors everywhere available in the field. You get continuously information, and on the moment, if it is necessary, you can get a good overview of the actual situation.
So a sensor network means that you have an individual sensor node, and that can be spatially distributed, and it's connected to one central place where the information is brought to the user. There are can be several steps in between, processing steps, or it can be only the raw data which are measured. Within our own group, we have developed a system where we combine remote sensing data with meteorological data to make a daily spatial estimate of vegetation productivity over the Netherlands. So, and these in fact are raster maps, which you also can easily incorporate into an SDI. Or SDI traditionally is very powerful in making data available to a broad community of users. And I think there is also the advantage of plugging dynamic data into an SDI and also making it available to a broad range of users.
It's not a real technical problem, it's more the problem of who will pay for it, who will give access to the data. There is a lot of political hesitance to publicize data who are not checked. The real old-fashioned experts, they don't trust the actual data so much. They really like more that every data should first go for a validation process. So there is still a lot of hesitance with the higher management in Holland.
Now, I think you can identify a little bit two ways how you can use these kind of sensor network systems. One is where you try to predict more or less what is going on. So you need sensor data as input for a prediction model in order to do some nowcasting, so what is going on in the coming hours, or to do also some forecasting. That is already what we see, of course, what's common in meteorology. When Gerrit Hiemstra is on television, then he's doing in fact the same, but you could also do that for more disaster management.
With earthquakes is that you know exactly as possible all the movements along the fault. You have the fault moving from this way to the other way, and sometimes it moves slowly, that means we're building up a lot of friction, and one time it can totally stop, and then it is getting a very dangerous situation, and it can suddenly shoot loss. And that is very carefully measured. You have a lot of sensors on both sides of the fault, and then you can predict maybe within 1 week or maybe within 1 month an earthquake can happen.
One example is, for example, that especially in Germany, the last few years they have set up a large-scale program in order to forecast the effects of tsunamis in the oceans. So after the large tsunami in Asia, something like 3-4 years ago, they have developed a system with buoys in the ocean, and they are now able to more or less, to a certain state, forecast the effect of earthquakes on what could become a tsunami.
It was first a small earthquake, and next to it was a very big fault with a lot of friction, and that small earthquake that triggered the big tension loose in the big earthquake, and really for hundreds and hundreds of kilometers a lot of energy was coming loose. Even big plate in the ocean came up 10 meters, and that triggered that huge tsunami. And now we have a lot of buoys everywhere in the sea, and they are measuring continuously if there is level change in the seawater. And if you see that, you can combine it with the power of the earthquake, and you can calculate how long it does take to get to the seashore. And then you can also calculate how big the wave will be going over the beaches and over the villages next to the beaches. So we can still do a lot about it.
So that is the forecasting part. The other important advantage of this kind of large-scale sensor networks is that you can also do something in mitigation of effects and also evacuation. So after a disaster has taken place, that you have information on what is going on, where are the people, what is the situation physically, where are the largest effects. So in that sense you can optimize your whole evacuation plan.
If you have seen a disaster situation, all the managers, the mayors of the cities, the center of decisions, they are crying for data. They are crying what really happens there, how dangerous is the situation there. So they really need good quality information as actual as possible, and not data from by phone from some neighbor or by uneducated people. They really should like objective sensor data to get that good information for their decisions. Yeah, the problem is that most effort is done after a disaster. So what we really need to have a good sensor network for combined information from all levels of water levels, then we need very good disaster